Dear students, welcome back. So today we'll finish the remaining part of the topic polynomials. Before we start the topic, before we continue with the topic, there are few questions asked by the students about the previous classes. So first of all, one such question is express 0.001 and 001 all are repeating decimals in P upon Q form. In P upon Q form. Now, as I have already told you, let x is equal to 0.001, then 001, then 001, and so on. Because these three digits are repeated again and again. Now, as three digits are being repeated, so we will multiply this whole equation 1 by 1000. So multiply equation 1 by 1000. Then we'll have 1000x is equal to, the decimal will be shifted 3 places towards right, so it will be 1.001, then 001, then 001, and so on. This is your equation number 2. Now from equation number 2, simply you subtract equation number 1. That means x is equal to 0.001, then 001, 001, and so on. Now when you subtract, you can see the decimal part in both the numbers are same, so they will be subtracted. 1000x minus x will be 999x is equal to 1, because 1 minus 0 is 1 only. So x will be equal to 1 upon 999, and that is your answer. So 0.001 and bar on 3 digits means 3 digits are repeated. When we convert it into P upon Q form, the answer is 1 upon 999. Okay. Now, one more thing. Square root spiral. Now what is square root spiral? Now in the previous class I told you how to plot irrational numbers, means the numbers with a square root, they are plotted on the number line. Now using that method only we make square root spiral. Now all of you pay attention. Suppose OA is a line such that OA is 1 centimeter. Clear? At point A, you make a perpendicular line, and suppose this is point B, such that AB is also 1 centimeter. Is it clear? OA is 1 centimeter and AB is also 1 centimeter. Now you know by Pythagoras theorem, this OB will be equal to square root of 2, because OB square is equal to OA square plus AB square by Pythagoras. So this is 1 plus 1, that is 2. So OB will be equal to square root of 2. So the length of OB will be square root of 2. Now at point B, you draw another perpendicular to OB like this. You draw another perpendicular to OB. let this point be C, such that the length of BC is again 1 centimeter. Okay, and then you join OC. Then you join OC. Once again, if you apply Pythagoras in triangle OBC, you can see that OC square is equal to OB square plus BC square, that is root 2 whole square plus 1 square. This is Pythagoras. Now 2 plus 1, that is 3. So OC will be equal to root of 3. So the length of OC will become root of 3. Clear? Now at point C, you draw a perpendicular to OC. At point C, you draw a perpendicular to OC. Let this point be D such that CD is again 1 centimeter. Okay? And again, if you join OD, so by the same method, you can show that OC square plus CD square is OD square. That is root 3 square is 3 plus 1. So square root of 4 will be 2. So this is nothing but 2. Length of OD will be 2, or you can say root 4, whatever. Now at point D, again you draw a perpendicular to OD. Draw a perpendicular to OD. And suppose this point is E and OD is again 1 centimeter. Then this side is 2, this side is 1. Again using Pythagoras, 2 square will be 4 plus 1 square is 1. 4 plus 1, 5. So using Pythagoras, you can say the length of OE will be root 5. Clear? Now on OE at point E, you draw another perpendicular, and this is point F. This is also 1 centimeter. And now if you join OF, so all of you can tell me that root 5 square is 5 plus 1, 6. So this will be root 6, and so on. You can continue this process infinitely. So this is called a square root spiral. Clear? Now we'll continue with our topic, that is polynomials. In the previous class, I told you about remainder theorem. So first we'll practice 1 or 2 questions from remainder theorem, and then I'll tell you about factor theorem. Polynomials. So there is a question, and the question is, find the remainder when 4x cubed minus 3x square plus 8x plus 5 is divided by 2x minus 1. So as I told you, first of all you put 2x minus 1 is equal to 0. That gives you 2x is equal to 1. So x is equal to 1 upon 2. Now in the whole expression, in place of x you have to put 1 upon 2, and whatever value you get, that is the remainder. Clear? So 4 into 1 upon 2 cube minus 3 into 1 upon 2 square plus 8 into 1 upon 2 plus 5, like this. Okay? Now see, 4 into 1 upon 2 cube means 1 upon 8, minus 3 into 1 upon 2 square means 1 upon 4. Here you can cancel it, it will be 4 plus 5. Now this is 1 upon 2 minus 3 upon 4 plus 9. 4 plus 5 is 9. Now you can see here, you can take 4 as LCM. So 2 minus 3 plus 36. Okay. So it is 36 plus 2. 38 minus 6, 35 by 4, and that is your answer. That is the remainder. The remainder is 35 by 4. Clear? One more question. The next question is, if 4x cube plus px square minus 5x plus 6 is divided by x minus 3 and the remainder is 171, then find P. The question is, if 4x cube plus px square minus 5x plus 6 is divided by x minus 3 and the remainder is 171, then find the value of P. Once again, applying the same method, put x minus 3 equal to 0. Then x is equal to 3. Now in the expression, if in the place of x you put 3, then you will get the remainder as said by the remainder theorem. So 4 into 3 cube plus p into 3 square minus 5 into 3 plus 6 will be the remainder. Now 3 cube, you know 3 cube is 27, 3 square is 9, minus 15 plus 6. Now 27 into 4 will be 108 plus 9p minus 15 plus 6. 108 plus 6 will be 114, minus 15 will be 99. So 99 plus 9. So we are getting the remainder as 99 plus 90, but the question says that remainder is equal to 171. That means 99 plus 9p will be equal to 171. So 9p will be equal to 171 minus 99. So 9p will be equal to 72. That gives you p is equal to 8. And that is your answer. P is equal to 8. Clear? Now, we will do a question that you have already done in class 8. Factorize 2x square plus 9x minus 5 by splitting the middle term. Factorize 2x square plus 9x minus 5 by splitting the middle term. So 2x square plus 9x minus 5. First of all, you have to multiply the coefficient of x square and the constant term. So 2 into 5 gives you 10. As there is a negative sign here, so you have to look for two numbers whose product is 10 and whose difference is 9, because there is a negative sign, and you know that is nothing but 10 and 1, because 10 into 1 gives you 10 and 10 minus 1 is 9. So we can write it is like that: 2x square plus 10x minus x minus 5. So you can see 9x can be written as 10x minus x. Now first two terms you can take 2x common, so it will be x plus 5. Last two terms, only minus sign can be taken as common, then again you will have x plus 5 in the bracket. Now x plus 5, same numbers here, so you can take x plus 5 common, and when you take x plus 5 common in the other brackets, you will have 2x minus 1, and that is your answer. This factorization you have already done in class 8. Now what I want to tell you, as you can see, the given expression has x plus 5 a factor and 2x minus 1 another factor. Now we are going to divide that given expression by one of its factors, say x plus 5. So when we divide 2x square plus 9x minus 5 by x plus 5, what happens? Here it is 2x square and that is x only, so we have to multiply it by 2x. So 2x square plus 10x, subtract. Now this is x and this is minus x, so you have to multiply it by minus 1. So minus x minus 5, again change the sign, and when you change the sign, the remainder left is 0. That means whenever a number or an algebraic expression is divided by its factor, then no remainder is left, or the remainder left is 0, and that is the factor theorem. The factor theorem says whenever a given algebraic expression is divided by its factor, then the remainder will be 0. So here is the factor theorem. If x minus a is a factor of fx, then fa is equal to 0. As I have already told you in the remainder theorem that fa is nothing but the remainder. Now here x minus a is a factor of fx, so the remainder has to be 0, so fa is equal to 0. So this is the factor theorem. Clear? Now we are going to do few questions on this factor theorem. We are going to do few questions on factor theorem. So the first question is, find k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Find k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Now, first of all, put x minus 1 is equal to 0, then x is equal to 1. Now you know, if in place of x we put 1 there in the given expression, then we will get the remainder. But according to the factor theorem, remainder has to be 0. That means 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k is equal to 0. As x minus 1 is a factor of the given expression, so the remainder should be 0. Now you see, 1 cube is 1 only, so 4. Again 1 square is 1, so 3. Minus 4 into 1, that is 4, plus k is equal to 0. Minus 4 plus 4 cancels out, so k is equal to minus 3, and that is your answer. So if x minus 1 is a factor of the given expression, then value of k will be equal to minus 1. Now the next question, factorize y square minus 5y plus 6 using factor theorem. Now all of you know how to factorize the given expression using that middle term splitting method, but here they are saying you have to factorize it using factor theorem. So what we do, first of all, you have to put y is equal to 1 in the given expression. Then after putting 1, then we will put minus 1, then we will put 2, we will put minus 2, and we have to see when we get a 0. So when you put y is equal to 1, so 1 square minus 5 into 1 plus 6. 1 plus 6, 7 minus 5 is 2, so it is not equal to 0. Now you put y is equal to minus 1. This is called hit and trial method. You have to put 1 minus 1, 2 minus 2 and so on. So minus 1 square minus 5 into minus 1 plus 6. Once again minus 1 square will be 1. 1 plus 6 is 7. 7 plus 5 will be 12, and again it is not equal to 0. Now you put y is equal to 2. When you put y is equal to 2, it is 2 square minus 5 into 2 plus 6. Now 2 square is 4. 4 plus 6 will be 10, and minus 10, that is 0. So you can see on putting y is equal to 2 is equal to on putting y is equal to 2 we are getting 0. That means y minus 2 is a factor of the given expression. Y minus 2 is a factor of y square minus 5y plus 6. Now you can see, as it is a quadratic expression, because the highest power of the variable is 2, so it's a quadratic expression. In a quadratic expression we have two factors. Similarly, in a cubic expression we will have three factors. So here we will have two factors, out of which one we have found. Now you divide the given expression by the factor you have already found, and you will get the second factor. So y square minus 5y, y square minus 5y plus 6. When you divide this by y minus 2, you will get y square minus 2y. Change the sign like this. Here it is y and minus 3y, so multiplied by minus 3. So minus 3y plus 6, again change the sign, and you can see the remainder is 0. So the other factor is y minus 3. So the factors of y square minus 5y plus 6 are y minus 3 and y minus 2. And that is your answer, y minus 3 and y minus 2. Clear? Now we will do one more example. And the example is factorize x cube minus 23x square plus 142x minus 120 using factor theorem. Now you see, as it's a cubic expression, means the highest power of the variable is 3, so we cannot factorize this expression by splitting the middle term also. So what we do, we'll apply the same method, First of all, you put x is equal to 1, then you put x is equal to minus 1, then 2 and minus 2 till you get a 0. So when you put x is equal to 1, it is 1 cube minus 23 into 1 square plus 142 into 1 minus 120. So 1 cube is 1 minus 23 plus 142 minus 120. Now you see 142 plus 1 is 143 and this is minus 143, so we are getting a 0. On putting x is equal to 1, directly we are getting a 0. So x minus 1 is one of the factors. Now tell me how many factors will be there in this expression? You are correct. There will be 3 factors because the highest power of the variable is 3. It's a cubic expression. So there will be 3 factors of this given expression. Out of the 3, we have got 1 factor. So now we will divide the given expression by this factor we have obtained. So x cube minus 23x square plus 142x minus 120, divide it by x minus 1. When you divide this by x minus 1, I'll use x cube and we have x here, so we will have to multiply it by x square. So x cube minus x square, change the sign, this is cancelled, minus 22x square plus 142x minus 120. Once again we will multiply it by minus 22x. So it is minus 22x square plus 22x. Again change the sign and it is 120x minus 120. So you multiply it by plus 120. So it is 120x minus 120. So you can see no remainder is left as expected. And the quotient we are getting is x square minus 22x plus 120. Now as it is a quadratic expression, means it will have 2 factors. So 1 factor we have already obtained and then 2 factors from here, there will be in all 3 factors. Now this expression, this is a quadratic expression, so it can be factorized by splitting the middle term. So as the constant term is 120 and there is a positive sign, so you have to look for 2 numbers whose product is 120 and whose sum is 22. So undoubtedly it is 12 and 10 because 12 into 10 gives you 120 and 12 plus 10 is 22. So you write it as x square minus 12 plus 10 into x plus 120. So x square minus 12x minus 10x plus 120. And now if you take x common, this is x minus 12 minus 10 common, so x minus 12. And again you take x minus 12 common, so in the other bracket you will have x minus 10. So the remaining 2 factors are x minus 12 and x minus 10. So the factors are one factor we have already obtained, x minus 1, x minus 10, x minus 12. These are the 3 factors of the given expression. Is it clear? Now after this, I am going to give you few identities. So you have to remember all the identities. Few of them you have already remembered, you have already studied in class 8. So few more are there. So the identities that we are going to use in this class are like this. First one is x plus y whole square is x square plus 2xy plus y square. I hope you have already done this in class 8. Then x minus y whole square is x square minus 2xy plus y square. Then third one x plus y into x minus y is equal to x square minus y square. These three you have already done in class 8. Now the next one, fourth is x plus a into x plus b is equal to x square plus a plus b into x plus ab. Now the fifth one, x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. And now the sixth one, x plus y whole cube, x cube plus y cube plus 3x square y plus 3xy square. And then the seventh one, x minus y whole cube, x cube minus y cube minus 3x square y plus 3xy square. That is the seventh one. And the eighth and the last is x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z in one bracket, and in the other bracket it is x square plus y square plus z square minus xy minus yz minus zx. Okay, so these are the identities that we are going to use to factorize various expressions in this chapter. Now, an example based on these identities is like this: 49a square plus 70ab plus 25b square. We have to factorize this using these identities. So first of all of you know that 49 is 7 square. That means we can write it as 7a whole square like this. Again 25 is 5 square, so it can be written as 5b whole square. And 70 can be written as 2 into 7a into 5b. Now you see it is nothing but 7 into 2 is 14 into 5 70ab. It is same 70ab. But now if you observe closely, this is x square plus y square plus 2xy. That is the formula for x plus y whole square. So you will write 7a plus 5b whole square. We have used x plus y whole square is equal to x square plus y square plus 2xy. We have used this identity here. Clear? And we can say it is 7a plus 5b into 7a plus 5b. So these are the two factors. Clear? Okay. Now one more example, and the example is 4x square. You have to factorize 4x square plus y square plus z square minus 4xy minus 2yz plus 4xz like this. Okay. Now see, 4x square can be written as 2x whole square. Now y square can also be written as minus y square plus z square. plus this this can be written as 2 into 2x into minus y. See, because it will become minus 4x. Similarly, here it can be written as plus 2 into minus y into z, and the last one plus 2 into 2x into z. Now you see it is written like this: a square plus b square plus c square plus 2ab plus 2bc plus 2ca, or x square plus y square plus z square plus 2xy plus 2yz plus 2zx. That means this is nothing but x plus y plus z whole square. Although we are applying the formula of x plus y plus z whole square, but as y, in place of y we have minus y, that is why it is 2x minus y plus z. Clear? So the formula that we have used here is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay, so this is your answer. Clear? Now the next question: find 104 cube using an identity. You have to find 104 whole cube using an identity. Although we know we can simply multiply 104 three times and we'll get the cube of it, but they are saying you have to use it using an identity. So we split 104 as 100 plus 4 cube. Now why we have done it like this? Why not 90 plus 14 or 80 plus 24? Because 100 is a number whose cube, whose square we can write orally. That is why 104 we have written it as 100 plus 4. Now this is x and this is y. So we can apply the identity x plus y whole cube. X plus y whole cube, you know it is x cube plus y cube plus 3x square y plus 3x y square, like this. Okay, so here we will mention the form the identity that we have used, which is x plus y whole cube is equal to x cube plus y cube plus 3x square y plus 3xy square, like this. Now 100 cube means after 1 you have to put 6 zeros. 4 cube means after 4, 4 cube is 64, and then 3 fours are 12 and 4 zeros, and then 4 square is 16, 16 into 3 is 48, 4800, like this. Okay, now you have to add them. So when you add them, you will have we will have 1124864, and that is your answer. When you multiply, when you add these numbers, you will get 1124864. Is it clear to everybody? So in this way we can find the cube of 104 using an identity. It makes the calculation easy also. Okay, now one more example. And that is, if x plus y plus z is equal to 0, then prove that x cube plus y cube plus z cube is equal to 3xyz. Now, to do this question, you just recollect the last identity that I have told you, which is x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z in one bracket, and in the other bracket it is x square plus y square plus z square minus xy minus yz minus zx. Now you simply see in this identity, they have already given that x plus y plus z is equal to 0. So in place of x plus y plus z, if you put 0, then you will have x cube plus y cube plus z cube minus 3xyz is equal to 0. So x cube plus y cube plus z cube is equal to 3xyz, and that is what we have to prove. But suppose the question says that without using the identity, you have to prove that x cube plus y cube plus z cube is equal to 3xyz if x plus y plus z is equal to 0. Without using this eighth identity, the last one, without using this last identity, if you have to prove this, then how will do it? So there is one more method for that, and the method is like this. Given x plus y plus z is equal to 0, then x plus y will be equal to minus z. Taking cube on both sides, x plus y cube is equal to minus z cube. Now here you apply the identity of x plus y whole cube, which is x cube plus y cube plus 3x square y plus 3xy square is equal to minus z cube. Now x cube plus y cube, bring it here, plus z cube, and from these two we can take 3xy common. So within brackets we will have x plus y is equal to 0. Now in place of this x plus y you put minus z. Once again in place of this x plus y you put minus z, then it will be x cube plus y cube plus z cube plus 3xy into minus z is equal to 0. That is x cube plus y cube plus z cube minus 3xyz is equal to 0. So we can say x cube plus y cube plus z cube is equal to 3xy. So without using the last identity, we have proved that x cube plus y cube plus z cube is equal to 3xyz if x plus y plus z is equal to 0. It is proved. So students, with this we have finished our polynomials. You have to do all the questions given in your assignments, as well as all the questions given in the exercise and examples. The PDF of the chapter is already given to you. So do all the sums and note down your problems, and that we will do once the school reopens. Thank you.